Hi guys, so in this video we'll be solving this problem Pepcoder and bits. So let's first understand what the problem says. Problem says that we will be given a number n. Okay, so what we have to do in the range 1 to n minus 1, we have to tell all the numbers which are smaller than n and which have same set bit count as that of n. Okay, so there are two conditions. In the range 1 to n, all the numbers which are smaller than n and which have same set bit count as that of n. So what do I mean by it? Let's suppose there is a number, let's take a number 10. So if the number is 10, so what we have to consider in the range 1 to n minus 1, that is from 0 to 9. So first let's write the numbers in the range 0 to 9. We 0 1 2 3 4 5 6 7 8 and 9. Okay, so let me write their binaries. So it will be 0 0 0. Okay, so these are the numbers in the range 1 to n minus 1, and our number is what, 10, and the binary of 10 is what, 1 0 1 0. So this is the binary for 10. So we in the range 1 to n minus 1 we have to consider all the numbers which are smaller than n, so and same number of set bits as that of n. Okay, since we are considering in the range 1 to n minus 1, so all the numbers will be what, obviously smaller than n. So this condition is automatically satisfied. Okay, second condition, we have to only ensure the second condition, that the number of bits are set bits is same in this number and the number in this particular range. So let's see, 9 is smaller than n and it also has what, 2 set bits. So this will be a potential, this is an answer. Okay, well, now consider 8. No, 8 is not an answer, since number of set bits here is what, 2, and here it is 1. So 8 is not an answer. Similarly for 7, if you check, number of set bits is what, 3. Here it is 2. So 7 will not be an answer. 6 is an answer, since 2 is 2 number of set bits. 5 is also an answer. 4 is not an answer. 3 is an answer. 2 is not an answer. 1 is not an answer, and we have to not consider 0. We have to consider in the range 1 to n minus 1. Okay, so if we see there are 4 numbers which are satisfying this particular, all these two conditions. So if n is given as 10, our answer will be what? Our answer will be 4, since there are 4 numbers in the range 1 to 9 which has same set bits as that of n equals to 10. Okay, so this was for the problem part. So this is what we have to do in this particular problem. Now let's see how we can solve this particular problem. Okay, so let me erase this part. Let's keep it, we may later need it. Okay. So how we are going to approach this problem? We are going to recursively, means we are going to look for a recursive solution for this particular approach. Okay, so let's one by one see what we are going to do. Let's suppose we are given a number n1. Okay, this is the most significant bit, and this part is what, least significant bit. Okay, now let's suppose this particular bit is what, 1. Okay, now I will, or let's suppose yeah, let's keep it 1. So now let's suppose I want to generate a number which is okay, let's make it 0 for now. Okay, now let's suppose I want to generate a number which is greater than n1. So what can I do? One thing is that I can make another number n2 whose this most significant bit is 1. Okay, now rest of the all bits, whatever are the rest of the bits, it does not matter, and 2 is what, greater than n1, since at most significant bit what we are getting, 1. Okay, so that is one particular way. Another way could be what, let's suppose, and this time n1 is what, n1 is 1 only, we are not making this bit as 1. Now if I want this number, another number n2 which is greater than n1, what can I do? One way was what, I changed this one bit to what, 0 over here. Okay, originally n1 was something like this, 1, and so on. Okay, 1 1, let's suppose n1 was like this. Okay, so one way was what, I changed this most significant bit to 0 and I made another number whose most significant bit is 1. Now let's look at the second option. Second option is what, I did not change the most significant bit of this n1. I kept it as 1 only. I changed the second most significant bit. So here I changed 1 to 0. So now this time what I can make, I can make n2 something like this, 1 and 1. Okay, so here we are seeing, okay, most significant bits are same. Okay, now second most significant bit is what, 1. Here it is 1, here it is 0. Okay, so this, that means what, again n2 is greater than n1. Now no matter what are the bits over here, n2 is what, greater than n1. So what we are seeing is that the position, that is the bit at the most significant bit, is what the deciding which number is greater than the other number. So we are going to use this fact to solve this particular problem. Let's see how we are going to use this. Let's suppose we are given a number something like this. There are k set bits in this number, k set bits this number. Okay, so here it originally 1 is present, okay, at this particular position. Okay, now we want what, numbers which are smaller than n. According to our problem, we want numbers which are smaller than n but have the same set bits, that is number of set bits is what, 1 only. So what we can do, one way is what, we can set this particular bit, it is 1, we can set this particular bit as 0. Okay, we set this bit as 0. Now in the remaining positions, let's suppose these are what, these are total of n position, this is an n bit number. Okay, so there will be n positions. So I fixed the most significant bit as 1, as 0. So now this number is smaller than this number, and now this is n minus 1. Okay, now no matter what is filled in these positions, this number n2 is going to be smaller than n. But I want what, k set bits in my number, so I will place k set bits over here. And in how many ways can I place k set bits? That is what I want to select k positions, so that will be n minus 1 ck. So this is the answer from this part. If I set this bit as 0, so this will be the answer. These many numbers are there which I will be getting from this part. Second option is that what I will do, I will not change this particular set bit. Okay, I will keep it as it is. Okay, now what is remaining, n minus 1 numbers are remaining. I will say I have used, I have used a set bit over here. Like initially I was using 0 bit over here, now I am using 1. So in my total k, my k will be what, get reduced by 1 since I have used 1 set bit. Now my problem reduces to what, n minus 1 comma k minus 1. Originally my problem was what, n bits and k set bits. Now my problem reduced to what, n minus 1 k minus 1. I will say that I am placing 1 at this particular position, and you n minus 1 bits and k minus 1 set bits. In how many ways can you make a number which is smaller than n and the number of set bits are equals to k only? You tell me, total number of ways will be same as yours answer. So what we are seeing is that we are recursively breaking it down to a smaller problem, and this will be broken down to more smaller problem, and eventually we have to write a base case and we will be able to solve this particular problem. So we are going to use this recursive approach. So whatever I have just now explained you, let's do it with an example so that it will be more clear. Like, okay, let's suppose what we will be doing is, let's suppose a number 10 is given to us, 10 this is the number given to us. So this is a 4-bit number and equals to 4, and number of set bits here is what, here there are 2 set bits. Okay, so there are two options. What we will do, this we want numbers which are smaller than this n, and number of set bits is what, 2 only. So one way of making smaller is that this one will be get converted to what, 0. We will place a 0 over here, and in the remaining positions we have to maintain this set bit count. Okay, so in the remaining positions, now if we place any number, it does not matter, since at most significant bit this n2 has 0 and it has 1. So n has 1, so n will be always greater than n2. So we can place any bits over here, but since we have to maintain the set bit count, so what we will do, we need to place 2 set bits over here. And in how many ways can I place 2 set bits? There are 3 positions. So in 3c2 ways I can place. And what is 3c2? 3 factorial upon 2 factorial into 1 factorial, that is 3 only. So there are 3 ways, and let's see what are those 3 ways. So those 3 ways will be it could be either like 110 or 101 or 011. These are the 3 ways from here. Okay, now another option could be what, that I will use this one over here. Okay, I will use this one over here and I will ask 010. I will ask 010 to go and find in how many ways can you find a number smaller than n having same set bit count. Okay, so I have used what, one set bit over here. Earlier I was using 0, so my set bit will what, reduce by 1. Now I have only how many set bits, k equals to 1. So I am solving a smaller problem. Okay, so now my problem reduced to 010 with k equals to 1. So now my problem reduced to this. So whatever will be the answer for this, the same answer will be for here also. So now let's see now what we are having. We are having 0 at this particular position. Okay, now let's before moving with 0, let's see one more thing. We were having initially 1 and we wanted to reduce to a smaller number. So if what we could do, we could convert, we were doing was converting 1 to 0. So we were actually going to smaller side. There are two options in binary, either 1 or 0. If we go from 1 to 0, then what we are means moving from bigger number to smaller number. But if we are already 0, then we cannot make anything smaller than 0. Like if we convert to 1, then we are moving towards a higher number. So this is something we do not want. So if we are 0, if the bit is 0, then there is no option with this particular bit. Okay, this bit cannot do anything. This bit will simply ask its neighbor that I cannot do anything, you go and find the answer. Whatever will be the total number of numbers that you can generate, the same numbers I can also generate. So if the bit is 0, then we cannot do anything, we will simply move on to the next bit. Okay, so our problem reduces to what, 10 with still k equals to 1 only, since we have used 0 bit over here, so k will not decrease. Okay, now we have to find the number of ways using 10, which means how many numbers are there which are still smaller than n using n0. Okay, so there are two options with this particular n. It can be converted to 1 or it can be converted to 0. So it says I will get converted to 0. Okay, so this particular bit is 0. Okay, now we have to place, there is only one place left and we have to put what, k equals to 1 set bit. So in one place, in how many ways can I place a set bit? There is only one way, that is 1c1. That is one way. Okay, so it will return value 1, that there is only one way. Okay, now another option was that this one would say what, I will be 1 only, 0, you go and find how many ways are there. Okay, so since we used a 1 over here, so k equals to 0 now. Okay, now since we are at 0 and we have already discussed earlier also that if we have a 0, then we have, and we do not have any option, like we cannot, since there are only two bits 1 and 0. From 1 I can convert to a lower number by converting to 0, but from 0 there is no option with 0, so we will simply move on to the next bit. Okay, so for 0 there will be no answer, we will simply return 0 from here. Since there are no more bits left after this 0, so we will simply return 0. Before solving this, moving to this part, let me analyze one more thing. Let's analyze one more thing, that is, suppose if there is a 1 bit number. Okay, then what is the answer? If there is only 1 bit number, okay, and this bit is 0, now we want to generate a number smaller than this. Is it possible to generate a number smaller than this 1 bit number having 0? Though it is not at all possible, there is no other number smaller than this, so we will simply return what, 0. Okay, now let's suppose this 1 bit, this position is 1. So there are two options. One option is what, this bit will say what, I will remain 1 only, or this bit will say okay, I will get convert to 0 and my 1 bit should be arranged in this part. Okay, so but if this bit says that I will stay 1 only, then this number and this number are same, we have not reduced the answer. So here also the answer is this is not a valid answer, 0 will be there. Okay, now one thing here, if I convert this 1 to 0, okay, so here number of set bits is what, 1, and here number of set bits is what, 0, but total number of set bits should remain same, right? So this is violation. Okay, so this is also not allowed. So in case of 1 bit, there is no possible way to reduce the number. So in case of 1 bit, we will simply return what, 0. Okay, so this is what we are going to use. This is a base case. This will be using, we will be using as base case. If n equals to 1, that is one bit number, we will simply return 0. So now let's continue with the answer. So here it was 0 and it was 1, so total there was one way, so it was only also returning one way, so we were returning what, one way. It will return one way. Here from we are getting three ways, so three ways, so total four ways. So there are total what, how many, four ways are there, in which means there are total four numbers which are smaller than this particular number and having same set bit as this particular number. Okay, and we have already solved for this number over here. Let's try to see what are those four numbers, and are there actually four numbers or what. Let's see that. Okay, so if you see, what is the binary for 10? This number is what, 10, right? This number is 10, so we want to look in the range 1 to 9. If you look in the range 1 to 9, how many numbers are there which are smaller than 10 and have same number of set bits, that is 2 set bits. So 9 has 2 set bits, this is one number. 8 has 1 set bit, 7 has 3 set bits, 6 has 2 set bit, 6 is one number, 5 has 2 set bits, okay, 4 has 1 set bit, 3 has 2 set bits, okay, 2 has 1, 1 has 1, 0 is not considered. Yeah, so there are four numbers and those numbers are what, 3, 5, 6 and 9. So these are the four numbers which have same set bits as 10, and they are also less than 10. Okay, so this is how we are going to solve this particular problem using this recursive approach. So like whatever we have learned till now, let's try to code it. Okay, so for coding, like we have been given this function, NCR function, which will help us to calculate this NCR part over here. Okay, so for like if we start this problem, what we need is that we need this number, we also need this how many set bits are in this number. So for that also there is a function given like count set bits. It tells us the number of set bits in this number. So let's calculate that. Integer k equals to count set bits of n. Okay, out solution of n, k and 63 n line. Okay, so what is this 63? Like here in this case, what we were doing, we were solving a 4-bit number problem, right? So we could solve 5-bit number problem, 6-bit number problem. Okay, so long is of what, 64-bit, right? Long is of 64-bit, and if we start indexing from 0, the last bit will be what, 63-bit. Okay, so we are sending the position of the last bit. Why? Because what we are doing, each time we are considering the position of the last bit, that what is the last bit, and we are converting whether to convert it to 0 or convert into 1. So we are starting with the last bit, and long is of 64-bit. That's why we are passing the index of last bit, that is 63. Okay, so that was for that part. Now let's try to code it. So what else do we need? So what we were doing each time, first what I was doing, I started with the first bit. There was two options, this bit could be 1 or this bit could be 0. Like in this case here, this bit was 0, here it was 1. So I need to know that whether it is a 1 bit or a 0 bit. So for that I will need a mask. So let's calculate a mask. Long mask equals to long 1 left shift of I. So I got a mask. Now let's calculate whether it is a 0 bit or 1 bit. So if n and mask, if it is equals to 0, then it means what, it is a 0 bit. Okay, and if it is a 0 bit, then what do we know, this bit cannot help us. So what it will do, it will simply ask the next bit from I plus I minus 1 to end, that you tell me how many ways are there, same will be my ways. Okay, like what I just now said, let me tell it again. Like suppose there are 4 bits, 0, 1, 2 and 3. So if this particular bit is 0, so it cannot help us. So it will simply ask from 2 bit that how many ways can you find a number smaller than n having same n set bits, you tell me, same will be answer for my case also. So that is what we are going to do. So if this is the case, we'll simply return solution, and number of set bits will be same, since we are using 0, we are not using set bits, so k will be same, and I minus 1. Else if it is 1, then there are two options. If it is 1, then there are two options. One option is what we can, this one can get converted to 0 or can get to 1. So if it is converted to 0, answer 0. So what we are saying that how many bits are remaining? See how many set bits are there. Okay, so if we are at third index, like suppose if it is a 4-bit number, so we are at 0, 1, 2 and 3 index, it is 1. So we have two options. If we set this bit as 0, then how many bits are remaining? 3 bits, and 3 is what? I, and k is the number of set bits. So in I, C, K, right? We want I, C, K. What we will do, answer 0 equal to NCR I comma K. Okay, let me erase this part and explain it. This is 0 bit, 1 bit, 2th bit and third bit. Okay, so if this bit is 1, so there are two particular options. This bit can convert to 0 or can convert to 1. So if we convert it to 1, 0, so it will be 0. And here I, value of I is what? Value of I equals to 3. So how many positions are remaining? Number of positions remaining equals to I. And how many set bits are there? There are k set bits. So what we want? We want to place k set bits in I locations. So what is the way? I, C, K, right? So that is what I have written over here. Okay, and another way could be what? Answer 1. That is, if I choose to place a answer 1 bit over here, then what will happen? If I choose to place a 1 bit over here, then I will ask to I minus 1 locations how many ways are there with you, means how many numbers can you guys generate, tell me that. My answer will also be same, and since I have used a 1 set bit, so my set bit will reduce by 1. Okay, so let's do that. So it will be that is a solution of n k minus 1 and I minus 1. Okay, and here it will be in not integer, it will be long since return type is long, otherwise we'll lose some data. And finally what we have to return answer 0 plus answer 1. Okay, now recursively we are solving this problem, but we need to write the base case. Okay, and as I have already told you earlier also, let's suppose if it is an n bit problem, so what will happen? If this bit is 1, then one option will be to choose 0, other option will be to what? Choose 1. Then it will reduce to n minus 1 bit problem. Again we can choose 0, choose 1, it will reduce to n minus 2 bit problem. Okay, if there is a 0 somewhere, then it will simply reduce to n minus 3 bit problem. Okay, and so on. Eventually it will reduce to 1 day to 1 bit problem. Okay, and we have already seen that if it is a 1 bit problem, then our answer is what? Simply, if it is a 1 bit problem, then our answer is what? Simply 0. Why? Because if it is 0 over here and we want to make a smaller number than this particular number, so there is no other number smaller than this number, so simply 0 numbers are there. Okay, if it is a 1 over here, we want to make smaller number than this. If I place 1 only, then this is not smaller than this, so there is 0 number of ways. Okay, and if I want to, if I place 0 over here, then here set bits was what? 1. Now I got what? 0 set bits. So set bit violation is there, so not possible. 0 numbers are there. So if it is a 1 bit number, so we'll simply return 0. And if it is a 1 bit number, then its index will be what? 0. So we will simply check if I equals to 0 in the base case. If I equals to 0, then simply return 0. Okay, so this was for this problem. Let's try to run this code. It is giving correct answer. Let's try to submit it. So it is passing. So this was for this problem. I hope you guys would have enjoyed the video.